Fabrication of MOSFETs, Introduction. In this chapter, the fundamentals of MOS chip fabrication will be discussed and major steps of the process will be examined. It is not the aim of this chapter to present a detailed discussion of silicon fabrication technology, which deserve separate treatment in a dedicated course. Rather than the emphasis will be on the outline of the process flow and on the interaction processing steps which ultimately they determine the device and the circuit performance characteristics. The following chapter now show that there are the following chapters now show that there are very strong links between the fabrication process, design process, and the performance of the resulting chip. Hence, circuit designers must have a working knowledge of chip fabrication to create effective designs and to optimize the circuits with respect to various manufacturing parameters. Also, the circuit designer must have a clear understanding of the roles of various mass used in the fabrication process and how the mass used to define various features of the devices on chip. The following discussion will concentrate on well-established MOS fabrication technology, which requires that NMOS and NMOS N-channel, both N-channel, NMOS and P-channel, PMOS transistors built on the same chip substrate to accommodate both NMOS and PMOS devices. Special regions must be created in which semiconductor type is opposite to the substrate type. These regions are called wells or tubs. P-well is created in an N-type substrate, or alternatively an N-well is created in a P-type substrate. In the simple N-well CMOS fabrication technology presented here, the NMOS transistor is created in the P-type substrate and the MOS transistor is created in the N-well, which is built into the P-type substrate. In the twin tub CMOS technology, additional tubs of the same type as the substrate can be created for device optimization. The simplified process sequence for the fabrication of MOS integrated circuits on a P-type substrate, on a P-type silicon substrate is shown in figure. The process starts with the creation of the N-well regions for PMOS transistors by impurity implementation into substrate, and then a thick oxide is shown in regions surrounding the NMOS and PMOS active regions. The thin gate oxide is subsequently shown on the surface through. Here you can see in this figure simplified process sequence for the fabrication of annual CMOS integrated circuits with a single polysilicon layer showing only major fabrication steps. Create annual regions and channel stop regions. Grow field oxide and gate oxide, thin oxide deposit and pattern polysilicon layer. Implant source and drain regions, substrate contacts. Create contact windows, deposit and pattern metal layer. Thermal oxide. These steps are followed by creation of N plus and P plus regions. Source drain and channel stop implants and by final metallization, creation of metal interconnects. The process flow sequence pictured in figure may at first seem to be too abstract, since detailed fabrication steps are not shown to obtain a better understanding of the issues involved in the semiconductor fabrication process. We first have to consider some of the basic steps in more detail. Thank you.